All right, hey everyone. Now that we have worked with arithmetic with fractions, now we will move to solving equations that involve fractions. So first we have to remember, what does it mean for a number to be a solution to an equation? So let's start with this example. Is x equals 4/5 a solution to x minus 3/10 equals a half? Let's first substitute 4/5 in for x and see if it works, if it gives us a true statement. So doing that, replacing x with 4/5, I'll write the rest of the equation. And let's go ahead and do this computation now. I'll definitely need like denominator. I know 5 goes into 10, so I'll rewrite 4/5 with a denominator of 10. I'll have to multiply 5 by 2, so 4 by 2 as well. So 4/5 is 8/10 minus 3/10. And does that give me 1/2? So we have to ask ourselves if that gives me a half. 8 minus 3 is 5, so this becomes 5/10. And is that equal to 1/2? And indeed it is, because if I divide both the numerator and denominator by 5, I get 1/2 equals 1/2, which is true. So this results in a true statement. Therefore, 4/5 is a solution to this equation. So yes. Now let's see about solving these equations. So last time what I did was, if someone gave me a proposed solution, I could tell you whether or not it is actually a solution. Now let's find that solution for ourselves. Okay, again, here, this is an equation, so here's the equal sign, and you think about having two sides to your equation. One on the left, one on the right. So whatever you do to one side, you have to do to the other. And our whole goal is to manipulate this equation so that I'm left with just my variable y on one side of the equation and the number, which will be our solution, on the other. So y plus 9/16 equals 5/16. The operation here is addition, so I'm going to undo the addition to get y by itself. So I will subtract 9/16 from both sides of this equation. So what I'm left with here is y equals, and here 5/16 minus 9/16. 5 minus 9, I have to think about that for a moment, should be a negative 4/16. All right, and now I know that this can be reduced because 4 does divide into 16. So I could divide both the numerator and denominator by 4, end up with y equals a negative 1/4. All right, we can always go through the process of checking our answer to see if this actually is a solution to that equation. So I'll plug negative 1/4 in for y here. So I'll have negative 1/4 plus 9/16 equals 5/16. And we're trying to see if that's a true statement. All right, in order to add these together, I need the same denominator. So I'm going to multiply top and bottom by 4. So negative 4/16 plus 9/16, does that equal 5/16? Negative 4 plus 9 is indeed 5. So I got 5/16 equals 5/16. Great. So this is the process of checking your work after you've solved the equation. All right, next problem. Let's solve 10q equals 44. And again, I'm solving for q. So here's my equal sign that will split me into two distinct sides of this equation. The operation that connects the 10 to the q is multiplication here. It's 10 times q. So in order to isolate the q, I'm going to have to undo that multiplication by doing division. So I will divide both sides of the equation by 10. So what I have now, 10q divided by 10, I just have q equals 44/10, which I think can be reduced. Both numbers have 2 as a factor, so I'll divide both the numerator and denominator by 2. So q equals 22/5. Great. All right, and you can go ahead and check your answer, but we will not do that in this video. Next example, go ahead and pause the video and give this example a try, and then play it for the solution. We're going to solve x over 7 equals negative 9. In order to get x by itself, we notice that the operation here is division. So to undo the division, we're going to have to perform multiplication. So if I multiply both sides of my equation by 7, 7 times x divided by 7, that will undo that operation for me and leave me just with x on the left. And on the right, I have negative 9 times 7, which gives me a negative 63. Sorry about that. All right, next example. Again, go ahead, write the example down, pause the video so that you can try it for yourself. Solve 3/4 x equals 24. Now I will I need to undo this operation here. So 3/4 x times x. I'd like to divide by 3/4, but we know that dividing by fractions is the same as multiplying by the reciprocal. So I'll just go ahead and skip that process and get right to multiplying by the reciprocal. So I'll multiply the left-hand side by the reciprocal, which is 4 over 3, and multiply the right-hand side by 4 over 3. So again, you should notice here, all of these factors will cancel and leave me with just x. X equals, and then 24 times 4 over 3. Again, the 24, you can think of it as a fraction over 1. And I might rewrite the 24 so I can see that factor of 3. 24 could be written as 3 times 8. And then I have that extra times 4 all over 1 times 3, which is 3. The factors of 3, I can divide those out, divide the numerator and denominator by 3. And what I'm left with is 8 times 4, which is 32 in the numerator. And if you like, it looks like everything is canceled out. There's always an understood factor of 1. So I could write that factor of 1 in the denominator. However, any fraction with a denominator of 1 is just a whole number. So you can write this as, simplify it to just 32. All right, so the main idea here was that we multiplied both sides of the fraction by the reciprocal of this coefficient here. Multiplied both sides by 4/3. All right, next example. Again, feel free to write the problem down, pause the video, and check your solution. Solve negative 3/8 w equals 72. So what I'd like to do, again, is multiply both sides of the equation by the reciprocal of this coefficient, basically dividing out the negative 3/8. So I'm going to go ahead and, because that negative 3/8 there's a negative sign, I'm going to put it in parentheses. I'd like to multiply by the reciprocal here, negative 8 over 3. So all the same numbers, just numerator and denominator are flipped. So what you do to the left, you have to also do to the right hand side here, negative 8 over 3. So again, I had negative 3/8 w, so I multiply both sides by negative 8 over 3. All right, that will cancel everything here, and again, the negative times the negatives gives me a positive now, so I'm left with just positive w on the left. And on the right-hand side here, 72 times negative 8/3. So positive times negative, I know my answer will be negative. And also, 72 can be thought of as 72 over 1. And hopefully there's a factor of 3 here hiding in the 72. 72 can be written as 3 times 24. And then you have this extra 8 here, all over 3. And those 3's you can divide numerator and denominator by 3. So what I'm left with now is 24 times 8. So w equals a negative 192. All right, one or two more examples here. All right, So I think you have all the tools you need to solve the equations in this section. And the next thing you'll be asked to do is to translate sentences into equations and then solve those. So let me give you a few examples of what those are going to look like. 2/3 of an unknown number f, is 18. So then I need to translate this into an equation. Of course, the word is here represents the equal sign. And 2/3, so I can write that as a fraction, 2/3 of f. So we saw this before. The word of really does indicate that you need to multiply. So 2/3 times f is, so there's my equal sign, 18. 2/3 of f is 18. All right, now I've got it translated. I will go ahead and solve. We will undo this multiplication by multiplying both sides by the reciprocal of that coefficient. Everything divides out, and I'm left with f on the left. And on the right-hand side, again, I think of this as 18 over 1. There's a factor of 2 here, and 18 divided by 2 is 9. So divide by 2, I'm left with 9. So what I have left here, 9 times 3 is 27. And in the denominator, 1 times 1 is just 1. So f is equal to 27. All right, one more example. And why don't you pause the video here and see if you can complete this one on your own and then check your answer. The sum of 3/8 and x is 3 1/2. All right, the sum, this indicates that we're going to be adding. And what are we going to be adding? These two quantities, 3/8 and x. The sum of 3/8 and x. So I will write 3/8 plus x. All right, is, that's my equal sign, 3 1/2. 3 1/2. All right, let's go ahead. Now that we have it translated, let's go ahead and solve. First thing that I'll notice, whenever you're dealing with an equation and you have a mixed number, those are really difficult to compute with. So I'm going to go ahead and convert that to an improper fraction. So 3/8 plus x equals 2 times 3 is 6 plus 1 is 7. 7/2. All right, now I'll go ahead and isolate the variable x by undoing the addition. So I will subtract 3/8 from both sides. So I have x on the left equals 7/2 minus 3/8. So notice we will need to get a common denominator here. 2 divides into 8, so I will just write everything with the denominator of 8. 2 times 4 is 8, so I'll multiply top and bottom by 4. 7 times 4, that's 28. So 7/2 is the same as 28/8. All right, let's simplify. X equals 28 minus 3, that'll be 25. X equals 25/8. All right, that's wonderful. You can leave your answer like that, or if the situation kind of calls for it, you might want to convert that back to a mixed number, just because they used mixed number in the statement of the problem. So we can go ahead and do that. So convert 25 divided by 8. It goes into 25 3 times with a remainder of 1. So we could convert that to 3 wholes with an extra 1/8. All right, good luck on your homework.